On July 23, 1999, Space Shuttle Columbia embarked on what would become one of NASA's most dramatic missions, where the line between disaster and success became frighteningly thin. As the engines roared to life at Kennedy Space Center, no one could have predicted the series of cascading failures about to unfold, nor the extraordinary way they would ultimately cancel each other out. The mission, STS-93, carried the Chandra X-ray Observatory, a massive scientific payload that pushed the shuttle's capabilities to their absolute limits. From the first moments of ascent, the spacecraft found itself balanced on a knife's edge between catastrophe and survival, saved only by an improbable combination of engineering, safeguards, and pure luck. The trouble began almost immediately after liftoff, when a small but critical component failed in the shuttle's right engine. A metal pin, designed to block flow through a compromised fuel line, worked itself loose and became a deadly projectile. This tiny piece of metal, no larger than a finger, ricocheted through the engine's complex plumbing at nearly 70 miles per hour, eventually puncturing 3 cooling tubes in the engine nozzle. Liquid hydrogen, the shuttle's crucial fuel, began leaking into space at an alarming rate. Yet in the controlled chaos of launch, with hundreds of sensors reporting data, this life-threatening breach went completely unnoticed by both the crew and mission control. The shuttle's computers, detecting an unexplained pressure drop, automatically compensated by increasing oxygen flow, a solution that temporarily maintained engine performance, while unknowingly accelerating the spacecraft toward another potential disaster. Running out of oxidizer before reaching orbit. At almost exactly the same moment, a completely separate electrical failure occurred that should have compounded the first problem. A wiring flaw in the payload bay, caused by an over-tightened screw that had been slowly wearing through insulation over multiple flights, finally short-circuited 5 seconds after launch. This electrical fault knocked out 2 critical engine control computers, one that served as the primary controller for the center engine, and another that provided backup control for the right engine. With these computers offline, the shuttle's remaining control systems began receiving conflicting data about engine performance. In normal circumstances, such a failure could have led to catastrophic loss of control. But in this extraordinary case, the electrical problem interacted with the fuel leak in an unexpected way that ultimately saved the mission. The shuttle's flight computers, now working with incomplete data, began making decisions based on faulty sensor readings. One particularly incorrect pressure reading from the damaged right engine would normally have been averaged out by the redundant computer system. But with half the computers offline, this bad data skewed the engine's fuel mixture in a way that accidentally compensated for the hydrogen leak. While the right engine was burning too much oxygen due to the leak, the center engine was now burning too little due to the computer error. This unlikely balance kept the shuttle's overall fuel consumption within survivable limits, though mission controllers wouldn't understand this delicate equilibrium until after the mission. Inside Columbia, Commander Eileen Collins and her crew faced a bewildering array of warning lights and system alarms. The electrical failure had triggered multiple caution and warning indicators, including a terrifying fuel cell alert that suggested possible loss of the shuttle's primary power generation. With limited information and no clear understanding of what was happening to their spacecraft, the astronauts maintained their professional composure, following procedures and trusting in their training. The true gravity of their situation, that they were simultaneously experiencing 2 unrelated but potentially fatal system failures, wouldn't become apparent until engineers pieced together the data after landing. As Columbia continued its desperate climb to orbit, the margin for error grew ever thinner. The damaged right engine, still hemorrhaging hydrogen, was consuming oxygen reserves at an unsustainable rate. The shuttle's flight computers, confused by conflicting data, struggled to maintain proper engine performance. Yet through this perfect storm of failures, Columbia somehow maintained just enough thrust to continue its ascent. When the main engines finally shut down after 8 harrowing minutes, the shuttle had achieved orbit with its fuel reserves nearly exhausted. Calculations later showed the margin was less than 5 seconds worth of burn time. Had either failure occurred without the other, or had their timing been slightly different, the result would almost certainly have been an abort scenario or worse. The post-mission investigation revealed just how close STS-93 came to disaster. Engineers determined that just 2 more damaged cooling tubes in the right engine would have caused the nozzle to overheat and fail catastrophically. Another few seconds of burn time would have completely exhausted the oxygen reserves. The electrical short could easily have affected different computers, potentially leading to complete loss of engine control. That all these failures occurred in precisely the way they did, with effects that counterbalanced rather than compounded each other, remains one of the most remarkable coincidences in spaceflight history. Despite these challenges, the mission successfully deployed the Chandra X-ray Observatory, which has since revolutionized our understanding of the high-energy universe. The crew returned safely to Earth, unaware until debriefings just how perilous their flight had been. For NASA engineers, STS-93 became a textbook case of redundant system design and the unpredictable nature of complex failures. The mission's legacy endures not just in Chandra's scientific discoveries, but in the hard-won lessons about spacecraft design, failure modes, and the delicate balance between engineering and fortune that defines human spaceflight. In the annals of space exploration, STS-93 stands as both a cautionary tale and a testament to human ingenuity, a mission that should have failed, but didn't, thanks to an extraordinary alignment of problems that somehow added up to a solution.